Hey everyone, in this video we are going to be solving literal equations with multiple variables. So this is lesson 8b. Hopefully you are following along in your notes packet. So you either printed it online if you're virtual, or you should have this in your notes from the packet from school. So your job usually will be to solve the equation for one of the variables. The letters that do not represent your desired variables move to the other side of the equal sign so that the one variable you are solving for stands alone. Even though there are more letters in these equations, the methods used to solve the equations are the same as the methods you use to solve all equations. So what's that? Normally when we're solving equations, we undo the order of operations. So first we undo addition, subtraction, then we undo multiplication, division, then we undo exponents, and then we undo grouping. So it's PEMDAS but backwards. So said Meg. Okay, so let's take a look at example number 1. We're going to look at an example that's just a regular equation where we're solving for x, and one that's very similar that has letters instead of numbers. So let's just look at numbers first for letter A. Okay, so if I'm solving letter A, I want to get x by itself. I would subtract 3 from both sides. Okay, I have 5x equals 30. And then I divide both sides by 5 to get x equals 6. Okay, hopefully you guys are super familiar with solving a two-step equation at this point. Okay. Now we're going to look at a very, very, very similar equation, but instead of a 5, we have an A. Instead of a plus 3, we have plus B. And instead of 33, we have C. But the steps and the methods are exactly the same because they're still asking us to solve for x. So all we're doing is trying to get the x by itself on the left-hand side of the equation. And I like to call this like rearranging equations or rearranging formulas, because you're really just moving the letters to the other side using the inverse of whatever operation it has. Okay, so let me put in my railroad tracks. Again, I'm trying to get x all by itself in the left-hand side. So just like this solution, I want to say x equals something. So first I'm going to undo any addition or subtraction. So the a in front of the x is multiplication, and then this b is being added. So I'm going to undo this plus b, just like I undid this plus 3 with a minus b. So I'm going to subtract b from both sides. So I'm going to bring down ax equals. And now you can't actually do c minus b because they're not numbers. So because I can't actually subtract, I'm just going to write c minus b, and that's all I can do. Okay. Now I'm still trying to get this x by itself. It has the a in front of it, and remember in class we've asked you many times, when there is a number in front of a letter, what operation is it? Well, now I have a letter in front of another letter. It still represents the same operation, which is multiplication. So how do I undo multiplication? Division. Just like I divided by 5 over here, because that was the number in front of the x, I'll divide by a over here because that's the letter in front of the x. So I'm going to divide this side by a, and then I can either divide the entire side by a or both pieces. Since I can't actually divide, I'm just going to put one long division bar and divide the entire thing by a. I can't actually do c minus b divided by a, so I'm just going to leave it as c minus b divided by a. Now x is by itself, so I'm going to just rewrite this. X equals, I can't actually simplify anything over here, so I'm just going to rewrite c minus b over a. Okay, that's my final answer. Okay, so again, I'm really just rearranging this equation so that the variables other than x, or other than the one you're looking for, go to the other side of the equation. Okay, now we're going to look at some formulas that are sometimes asked to be rearranged. So a formula is an equation that describes a relationship among quantities. You can rearrange a formula using inverse operations and properties of equality to isolate any variable in that formula. This is called solving for a variable. The result of solving a formula for a variable is not a number, but a variable expression itself. Okay, so the first example is for the volume of a cylinder. So this formula can be found on your formula sheet or your reference sheet that you get on the day of the Regents, and you'll get anytime you take a test or quiz. So this is the formula for the volume of a cylinder. So you have your picture of the cylinder over here. Okay. Now it says the positive value of r in terms of h and v is. So what that's asking is they want us to solve for r, and in terms of h and v means that you're going to have an h and a v in your answer. So it's not going to be r equals a number. It's going to be r equals and then something with a whole bunch of other letters. So I'm going to rewrite my formula over here. Let's move up a little bit so I have more room to write. Okay, so I have v equals pi r squared. So that means pi times the radius squared h. So what that really means is pi times the radius squared times h. Okay, so I'm solving for the positive value of r. So I'm trying to get the r by itself. So what do I need to get rid of that's over here with the r? Let's see. I have a pi symbol, I have an exponent of 2, and I have an h. Remember, when we undo operations, we want to go in the opposite of the order of operations. So first I want to undo addition or subtraction. Do I see any addition or subtraction over here? I don't. Do I see any multiplication or division? I see multiplication. So remember, this pi in front of the r squared is really multiplication, and the r squared and then the h next to it is also multiplication. Okay, so I actually want to do two things that are being multiplied. I can undo them at the same time since they're just letters. So I'm going to undo multiplication with the opposite, which is division. I'm going to divide this side by both things that I'm multiplying by r squared. So I'm going to divide by pi. I'm also going to divide by h, and I can do that at the exact same time, which makes this a lot simpler than it would be if they were numbers, because I can just put them both down there and they both cross off. Okay. If I do it to this side, I have to divide the other side by the exact same thing. So I'm going to write divided by pi h as well. Can I do v divided by pi h? No, they're not numbers. So I'm just going to leave it as v over pi h equals, and then what's left on this side that I haven't used yet? The r and the squared. Okay. The r is not by itself just yet because I still have this square sign. So I need to think of what the opposite of a square is, and that's a square root. So the opposite of a square is a square root. What I'll do is I'm going to take the square root of each side. So I'm going to take the square root of this and the square root of this. So you put one giant square root sign around the entire side. So the square and the square root cross off. So I like to do this to cross them off. So I have r left on this side because the square and the square root crossed off. And I can't actually take the square root of v over pi h because they're not numbers. So I'm just going to rewrite it. The square root of v over pi times h. Okay, let's look over here at my answer choices. Okay, which one looks like this? That's right, choice 1. This is actually the Regents exam's favorite question to ask. It's been on there almost every single year. So as long as we have a Regents exam this year, you can bet that this question will be on there. Students sometimes, some years, even end up memorizing it because we see it so often and it shows up so much. Okay, example number 3 is pretty similar. Okay, this one is the formula for the volume of a cone. So the volume of a cone, so that's something that looks like this, okay, is v equals 1/3 pi r squared h. So it's similar to the last equation or the last formula, but we have this 1/3 in here, and I wanted you to see what it would look like when you have a fraction as a coefficient. Then it says the radius r of the cone may be expressed as, so see this r, we are solving for r again. So I'm going to rewrite my formula over here. V equals 1/3 pi r squared h. Okay, so similar to the last question, first I want to undo any addition or subtraction. Do I have any addition or subtraction on this side? No. Do I have any multiplication or division? Yes. Okay, so this 1/3 is really being multiplied by pi, which is being multiplied by r squared, which is being multiplied by h. Remember, I'm trying to get the r by itself. So first I want to get rid of this multiplication of a fraction. This I have to do separately because to undo this, instead of dividing by the fraction, we want to actually multiply the entire side by the reciprocal. So if I multiply this whole side by the reciprocal of 1/3, what is the reciprocal of 1/3? I hope you said 3. So I'll multiply this side by 3. I'm also going to multiply the left-hand side by 3. What is 3 times v? 3v. And then the 1/3 and the 3 cancel. And I'm left with pi r squared h, which is, again, very similar to the question before. Okay, still trying to get r by itself. So now I want to undo the rest of the multiplication. Remember, there is really multiplication here and here. So I'm going to undo that multiplication by dividing both sides by pi and h. So those cancel. And I have to divide the left by pi h as well. Can I do 3 times v over pi h? No. So I'm just going to bring it down. 3v over pi h, because there's nothing I can really do. Okay, on the right-hand side, I'm going to bring down r squared. Okay, my last step is to undo this square by doing the opposite, which is a square root. Take the square root of both sides. So this and this cancel, and I'm left with r equals this whole thing. So let me just rewrite it. The square root of 3v over pi h. Now this might look super confusing, but remember, you're not actually doing any of the operations. You're just moving letters from one side of the equation to the other. You're just rearranging these letters. So now let's take a look at the answer choices. Which one matches this? I hope you said choice 1. Okay, let's look at one more together, and then we'll have you do the independent practice on your own. So Boyle's law involves the pressure and volume of gas in a container. It can be represented by this formula here. P1 times P2 equals P2 times V2. Okay, so these little subscripts are just saying P1 is one pressure and P2 is a different pressure. So they're both P's because they involve different pressures, but the 1 and 2 are saying that they're representing different pressures, and the V1 and the V2 are both different volumes. Okay, so I'm going to go ahead and rewrite my formula on the side. P1 V1 equals P2 V2. Now I have to go back to my question and figure out what I'm solving for. It says when the formula is solved for P2, the result is. So I'm trying to get P subscript 2 by itself. I'm going to go ahead and circle this whole thing over here. Okay, so I want this by itself, which means I have to get rid of the V subscript 2. These two things are being multiplied together. So how do I undo multiplication? I hope you said division. So we're going to divide both sides by V sub 2. These cancel. And can I actually do any division over here? No, because they're just letters. So I'm just going to bring it down. I have P1 V1 over V2 equals P2, and that's my answer. So I'm just looking for this as an answer choice. Let's see, right here as answer choice 3. Okay. You are going to try the independent practice on your own. So it says the volume, it's the volume formula for a rectangular prism, and we are solving for H. Okay, so here's your equation, and you're trying to solve for H. Okay, hopefully you wrote this. This is an L, not a 1, because the volume of a rectangular prism is length times width times height. I'm trying to get H by itself, so I hope what you did is you realized this was all multiplication and you just divided both sides by L and W. They cancel, and I can't actually do the division, so this is my final answer. I'm just going to rewrite it to say H equals V over L W, and that's it. Let me know if you have any questions.